Let's solve a problem on potential energy. So what we have here is we have this mass which is 2 meters above the ground, and this mass is 2 kilogram, and there's a spring down here on which this mass is going to fall. The spring constant of this spring is 1000 Newton per meter. Okay, so the question is how much the spring will compress if the mass falls on the spring. And let's also assume the unstretched length of the spring is given as 0.2 meters, right? So what should we do? How much we are going to compress the spring? So how would we solve this? Let's say we will compress the spring by length x. Let's say this is the compression. So what is happening? This guy who has a potential energy because of gravity falls down, and the gravity does work on this mass, and as it does work on it, the potential energy actually changes to kinetic energy. And when it reaches somewhere here, it has a lot of kinetic energy but a small amount of potential energy, and it falls on the spring, and the spring gets compressed because of that. So this kinetic energy now does work on the spring and increases the potential energy of the spring, and by the end what happens, the object comes to rest, and all we have is a compressed spring, and this object is some height above the ground, right? So our final diagram will look something like this. This was the unstretched spring, this is the stretched or compressed spring, this is the compressed spring, and we are assuming that this got compressed by a distance x. So how should we solve this? Well, it's just a matter of changing the change of potential energy from gravitational to the spring potential energy. So let's start first of all to calculate how much potential energy the mass has initially. Well, we already know the potential energy mass has initially is all because of gravitation. So all the energy is actually gravitational potential energy, and we know that particular potential energy, that is gravitational potential energy, is given as mgh. For the sake of simplicity, let's assume g to be 10 meters per second square, and this is 2 multiplied by 10 multiplied by 2, and that gives us 2 to 4 and 40 joules. Joules is the unit for energy. Okay, let's talk about the final state now. In the final state, we have assumed that the spring has gotten compressed by length x. So if it has gotten compressed by length x, then what is the energy then? Well, we know there will be half kx squared energy because of the compression of the spring, but this guy is still above the ground, so it also has got some potential energy because of the gravitation. And how much is that? The amount of length it is above the ground is 0.2, which is the length of the spring, minus the compression x. So this length is 0.2 minus x, because this is 0.2 and this is x, multiplied by gh, which is 20. This should be same as what? Well, we started with 40, we should end with 40. We are not really losing energy anywhere. So if you solve this, k is 1000, so we get 1000. You can do that yourself, but I'll just do it fast. We get 1000 x square plus 8 minus 40x equals 40, right? And if we rearrange this, what do we get? We get 1000 x square minus 40x minus 32 equals 0. Or you can also write x square minus 0.04 x minus 0.032 equals 0. And if you solve for x, because it's a quadratic equation, we get 0.04 plus minus square root of 0.04 square minus 4ac, which is plus 0.032 multiplied by 4 divided by 2, right? I was doing something on my head, so this is the final answer for x, because it's a quadratic equation. Now, which one of these should we take? Should we accept as the right answer? We have two answers. Well, we should accept the plus one. Why? Because the other one is a negative number. You see, this whole thing is bigger than 0.04. So if we accept the other answer, the negative one, we get x to be negative. But x is not negative, actually x is positive. The spring is getting compressed, so x should be a positive number. So the physical solution is going to be plus, now you can do the calculation using your calculators, plus 0.032 multiplied by 4 divided by 2. That is the answer. I make my own problems, that's why I don't really get very beautiful answers, but I hope it conveys the message. We'll discuss a few more examples on potential energy, and this time we'll also include kinetic energy and friction. Let's do that in next 2 lectures.